Okay, so raw data. Okay, so I want everybody to think of how many siblings you have. How many siblings do you have? Everyone have that number in their head? Okay, we're going to go through the class and we're going to have you guys tell me. Starting with the far end over there. How many siblings do you have?
Oh, 3.
3. Next.
2.
2. Next.
1.
Next.
Hi, sorry.
That's right. Next. Next.
2.
Next.
1.
Next.
2.
Next.
0.
Next.
2.
Next.
3.
Next.
3.
Next.
7.
Next.
I'm
Next.
sorry.
1.
Next.
Yeah, me too.
Next.
1.
Next.
2.
Next.
1.
Next.
4.
Next.
3.
Next.
1.
Next.
4.
Next.
1.
Next.
2.
Next.
3.
Next.
1.
Next.
1. 3.
Okay, good. All right, great. So that's our raw data. That's what raw data looks like, just like that. Boom. Okay, so that's good. It's data, but it's not really easy to read. Does that make sense? It's kind of hard to like figure out what's going on with it. So what we do is we have this thing called a frequency distribution table. So a frequency distribution table is when we take all this raw data, we organize it into classes. Right? So then we have classes, like here, how many siblings do you have? Maybe you have to tally. This part's optional, but sometimes it helps to kind of tally how many you have as you're going through the data. And then the frequencies. So let's see, what do we have? We've got 0, 1, 2, 3. We've got 4, 5, 4, 5, 7. 4, 5, 7. Okay, good. So I've got 1, 2 zeros. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. I've got 1, 2, 3, 4, 5, 6, 7 twos. I've got 1, 2, 3, 4, 5, 6 threes, a lot of threes. I've got 2 4s. Oh, yep, I got 1 5. Where did my 7 go? Oh yeah, there it is. 1 5 and 1 7. Okay, good. All right, excellent. So, how many classes are there? 1, 2, 3, 4, 5, 6, 7. Does anybody have 7?
Yes.
Well, I can count them. I got the 0 class. I've got the 1,
Yes.
2, 3, 4, 5, 6. What if I told you that, so wait, I got 7? What if I told you there's actually 8 classes?
0.
I told you there's actually 8 classes. Here's the deal. Yeah, I'm missing a 6. Is that I can't go 0, 1, 2, 3, 4, 5, 7 and skip 6. So there's really an indivisible class and there are 6. How many people have 6 siblings? 0. Does that make sense? So how many people have 3 siblings? 6. How many people have 4 siblings? 2. How many people have 5 siblings? 1. How many people have 6 siblings? 0. How many people have 7 siblings? 1. Right? So you can't leave gaps in there. So there's actually 8 classes. Good? Okay. It's really worked out nicely there. Okay, so I think you guys kind of have a handle on that. Let me ask you another question. What if it's impractical to have every value have its own line? For example, coffee. How many days a year do you drink coffee? Not how many times a day do you drink coffee, but there's 365 days in a year. How many of those 365 days do you drink coffee? So I want to think about how many days out of the year, 365 days out of the year, how many days do you drink coffee? Everybody have it in their head?
360.
Okay. All right, so we're going to start in the, I'm going to do it on the whiteboard.
I'm a barista, so I drink a
Oh,
lot of coffee.
yeah, makes sense. All right, you guys ready? In the back, ready? Go. 20?
100.
100? Next.
Try to put this in perspective. 0.
Next.
It's not half the page.
Next.
200.
Next.
Also.
Next. Where are we? All right, great. Next. 5.
72.
Next. 300. Next. Next. 250. Okay, next.
100.
Next.
150.
Next. Next. Where are we?
350.
Next.
120.
Next.
0.
Next.
Try to have more spice.
300.
No, have more spice.
Sorry, you guys, I can't hear him. Sorry, what'd you say? 340. 340. Next.
100.
Next.
365.
Next.
0.
Next. Oh, you guys, I can't hear folks. What was it? 24?
250.
24. 250. Next.
100.
Next.
300.
Next.
365.
Next.
0.
Next.
200.
Next.
350.
Next.
365.
Next.
323.
Next.
180.
180? All right, good. All right, so there's my raw data. Here's my question. How, it's impractical to, I can't have a single line for every single day of the year, that's impractical. Here's my data. I have data already. I can't go out and get new data. This is the data I have to work with. How do I show this data? What can I do to show this data in some sort of effective way? So 30 seconds to the neighbors. Why don't you guys talk about that? Here's the data of everybody.
Like, would you do it? Smallest to biggest.
Okay, does anybody have any ideas? Anybody have an idea? People, I haven't heard from you yet, but
Maybe you could like measure how many people get between 1 and like 75, or between 1 and 50.
okay, so yeah,
And
so,
measure between
yeah, it's like 1 and 50 or 0 and 50, and then
50 and 100.
yeah, so put them into groups,
Yeah.
right? That's exactly what we do. We put them into groups. Good. All right, so here's our group frequency distribution. 0 to 60, 61 to 121. Wow. Okay. Yeah. So I'll tell you what. Let's get someone to read them off for me. Molly, go ahead and read from me each number.
20,
Mhm.
100,
Yep.
0,
Yep.
200,
Yep.
200, 0, 0, 5, 300, 250, 100, 150, 350, 120, 0, 340, 100, 365, 0, 24, 250, 100,
Yep.
300,
Yep.
365,
Yep.
0,
Yep.
200, 350, 365, 323, 180.
Great. Okay, so I had 9, 5, 2, 3, 4, and 7. Good. Nice. Great. So now let's ask you a couple questions. One, how many classes are there now? How many classes are there in this situation?
6.
6. Good. 6 classes. Is each class the same size? Talk to your neighbors about it. 15 seconds to talk about it.
Maybe? Yes, it is. And reality. Well, I think that, yeah, I think that's all 365 divided by R, I guess.
I can't do math either, so I would hear.
Yeah.
All right.
I would have pulled my phone out.
All right. Bring it in, guys. Are they the same size?
Yes.
Yeah, actually they are. Yeah, they all are. They all have 61 items in them, 61 days in them. Good. Cool. So then that's important. They should be the same size. It's one of the critical elements of this. All right. So let's talk about a couple other things. It's also useful to find the percent of the total that each class represents. We call this the relative frequency because it shows how the data is related to the whole. So I kind of think of relative frequency like ratio R relative. It's the percentage that's in each class. So how do you do it? You find the total frequency, in other words, how many data items do you have all together, and then find a fraction that is in each class, right? So you take the frequency of the class, divide by the total frequency, and then write it as a decimal. The reason why decimal is easier is because when you create a histogram for it later, it's better to have numbers on the side instead of trying to have different fractions on the side. That makes no sense, whereas these numbers is kind of cleaner. So I'll show you what I mean by that. All right, so actually for 952347, 952347. We have a total of 30? Exactly 30? Well, that's convenient. Okay, so 30 people. So relative frequency, this would be 9 out of 30. Same as 3 out of 10, so that's 0.300. Yeah? Yeah. Okay, great. And this is 5 out of 30. 1/6, 0.187. So help me out here, somebody do it. Sure. 5 divided by 30. I think it's 1866. 167. Oh, sorry, my bad. 167. My bad. Okay, good deal. This would be 2 out of 30, which is. Oh, I'm sorry, what's it again? 0.067. Great. 3 out of 30, that's easy. 0.100. 4 out of 30. 133. 7 out of 30, which is 0.233. Perfect. Good deal. Excellent. When you add all these up, they should equal 1 or 100%. Sometimes they'll be off a little bit because of rounding. They might be like, off by like 1 decimal place, possibly. But you know it really adds up to 100%. All right, good deal. Excellent. Cumulative frequency. This counts how many data points are in that class or previous class. In other words, how many data points up to and including that class. You guys all know what it means? Like, what does it mean when snow accumulates on a windowsill? Kind of keep piling on, right? Who's ever heard of cumulative GPA or cumulative final? It means everything from the beginning up to that point. Right? So that's what this cumulative frequency is. It's everything, all the frequencies in the beginning up to that point. So, let me show you what I mean. We'll add a little area over here for cumulative frequency. All right, so this first class has 9 people in it. There are no classes before it. So its cumulative frequency is 9, because there's no classes in front of it, right? So cumulative frequency of the first class is 9. This next class has 5, but you have to look at all the classes before it. So it's 5 plus 9, 14. Everybody on board so far? Next one, 2 plus 14 before it, 16. Does that kind of make sense? And now you start 3 plus 16 before it, 19. Next class, 4 more, 23. Next class, 7 more, 30. Good? At the end, you better end up with the total here, or else you've done something wrong. All right. So everybody good with that part? Now, cumulative relative frequency, you'll notice in your notes, there's something called cumulative relative frequency. It's when you do both. It's when you do cumulative frequency on the relative frequencies. So it's like when you take, you can either take this number and then turn it into percentages, or you take these numbers and you add them up. Either one. But it's when you do both things to them. You get the same answer either way, regardless of which one you do first. When you change it to percentages and then add them, or whether you add them first and then change them to percentages. But it's when you do both things to them. So that's the cumulative relative frequency. Okay. So then there's also these things called categorical frequency distributions. It's when you use categories data, as your data. For example, your shirt colors, hair color, what year that people are in school, gender, whatever type of pizza toppings you want to order, stuff like that. Categories. So you guys, actually the very first problem, the very top of your page, is this problem here. You guys are going to create a frequency distribution table for this. What are your options? What are the things you're looking at? Like cats, houses, what?
People's
Blood types. Yeah. So your things are going to be blood types. How many blood types do you have? 4. Good. A, B, O, and AB. So that should be the beginning of your stuff.
Would you like us to just find the relative frequency?
Um,
And anything you need to find it?
on the frequency on the relative frequency board. So you guys are going to do your blood types. You're going to find your frequencies of these, and you're going to find the relative frequencies of them. All right, so, I'm sorry, I know my writing's bad. All right, so get to it.